discussion with having introduce ourselves first. So let's start with me. I'm Amalina.
Hi everyone, my name is Mia. Hi.
Hi.
Hi, I am Aisha.
Hi, Aisha.
Let's start our discussion for today. Are you guys ready? Yes.
Ready?
So let's start into our topic for today, which is technique or differentiation. So Ai, what is differentiation?
So differentiation is actually pretty simple, where differentiation is a method in calculus to find the rate of change of a function. It's like how fast a car is going or how the temperature changes over the time. In math, it helps us to find the slope of a curve, how flat something is at certain point. If you have a graph that's all curvy and wavy, differentiation helps you see where it's going up, where it's going down, or how far it's flat. And when you see something like dy over dx, that's actually a differentiation. So basically, it's like a tool that lets us read how things are changing, and that's what makes calculus so cool.
Right. So next, we are going to the questions. We are going to look through all the questions here. For the first questions, explain the meaning of differentiation and what are the technique of differentiation. So I already explained what is the differentiation, but I can simplify is differentiation is a way to find how fast something is changing, like the slope of a curve. And the answer we get is called a derivative, which show the rates of change. So the main technique are the power rules, constant rules, product rules, quotient rules, sum rules, and chain rules. Next. So let's move on to the next question, which is the calculation. So the question is saying that find dy over dx for the following function for y equal to square root 3x squared times secant x squared plus 2. So for the first step, let's simplify the equation. First, we take the equation square root 3x squared equal to square root 3 times absolute value of x. So it will be square root 3 times absolute value of x times secant x squared plus 2. So we just multiply the first equation and the second equation. So for the next step, we will use a product rule, which is include u and v. For the u, we take the first equation, which is square root 3x, and we will derivative of the equation, and it will become square root 3. So for the next one is v, secant x squared plus 2, and we will repeat the equation, it will become secant x squared plus 2, tangent x squared plus 2 times 2x. For the v prime, we will use the chain rule. For the third step, we will substitute into the formula, which is product rule. Dy over dx equal to u prime v plus u v prime. So it will become square root 3 times secant x squared plus 2 plus square root 3x times secant x squared plus 2 times tangent x squared plus 2 and times 2x. So for the final answer, it will be square root 3 secant times x squared plus 2 plus 2 square root 3x squared times secant x squared plus 2 and times tangent x squared plus 2. So I have a question. I'm sorry for interrupt, but I have questions. I don't quite understand what is chain rule. So if you could explain back to me what is chain rule, I would appreciate that. Okay, thank you Mia for the question. So according to my understanding, chain rule is a formula that we use to find the derivative of a composite function, a function made up of two or more functions. So the formula is dy over dx equal to dy over du times du over dx. So as we already know about the chain rule, we also need to know about the product rule. So product rule is a formula used when you want to differentiate the product of two functions, which is dy over dx equal to u prime v plus u v prime. For the next question, b, we will cos x plus 2 divided by sin x. So for the first step, we use a quotient rule, which is dy over dx equal to du prime minus u v prime over v squared. So we will take the first equation to be the u and the second equation to be the v. For u, we will take negative 5x plus 2 and we will differentiate it and it will become u prime, which is negative 5. So for v, it is sin x and we will differentiate it and it will become cos x. So for the next step, we will substitute into the formula. It will become dy over dx equal to sin x times negative 5 minus negative 5x plus 2 times cos x over sin square x. So for the final answer, we will get dy over dx equal to negative 5 sin x plus sin x plus 2 times cos x over sin square x. Let me explain a little bit about the quotient rule. The quotient rule is used when our differentiation fraction or equation of two functions. So we use a formula of dy over dx equal to du prime minus du v prime over v square.
So let's look at question 3, which is the structure is that given y times load at x minus e to the power of 2x plus 1 minus cotangent 4y equals to 0. We just need to find dy over dx by using implicit differentiation. So let's look at our calculation. For the step 1, we need to differentiate both sides with respect to x. And as you can see that the equation, we need to put d over dx on the both sides. And when we differentiate 0, the answer is going to be 0. The next step is we need to allocate all terms with dy over dx on one side of the equation, which means that we need to differentiate each term. You can see that I highlight the term that we need to differentiate. We will go one by one. So at first, you just can see at the top right side, which is y times load 9x. We need at here, we need to use product rule. So for the u, we'll take y, and for the v, we're going to have learn at x. After we differentiate y, we will get dy over dx, and after we differentiate learn at x, we will get 1 over net x times 9. So here we can cross 9, and we will get the answer is 1 over x. The answer for this differentiation is learn at x dy over dx plus y over x. And for the next is e to the power of 2x plus 1. We will differentiate 2x, and we'll get 2, and when we differentiate y, we'll get 0. So the answer is going to be 2e to the power of 2x plus 1. And next is we will differentiate cotangent for y. So when we differentiate cotangent, we will get negative cosec square and for y. And next we need to differentiate for y. When we differentiate it, we will get 4 dy over dx. And the answer is going to be negative 4 cosec square 4y over dx. And we will rewrite it. And the answer is going to be ln x dy over dx plus y over x minus 2e to the power of 2x plus 1 minus 4 cosec square 4y dy over dx equal to 0. And for the next step is we need to group the dy over dx, which means that we need to divide the term that have dy over dx and the term that did not have dy over dx. So as you guys can see there, I have highlighted the term that did not have dy over dx. So they will go to the right hand side, which means that we will put together dy over dx on the right hand side. So it will be ln x dy over dx plus 4 cosec square 4y dy over dx equal to 2e to the power of 2x plus 1 minus y over dx. Next step is we will leave dy over dx alone. This means that we will move the equation that have the dy over dx to the right side. So we move ln x plus 4 cosec square 4y to the right side, and we will be divide. So the final answer is going to be dy over dx equal to 2e to the power of 2x plus 1 minus y over x divide with ln x plus 4 cosec square 4y. So that is the final answer for the question 3.
Alright, for the last question, which is question 4, the question is use linear approximation to estimate the value of square root of 160.01 minus 2 over square root 160.01. So first, we need to define the function first. But before we define the function, of course, we need to find x first. So here, I let 160.01 become x. So the function from the functions, it becomes fx is equal to square root of x minus 2 over square root of x. But to make it easier to differentiate, I rewrite it using the power, which is x the power of 1 over 2 minus 2x the power of negative 1 over 2. The second step is to differentiate, which is find the derivative. For this, we use the power rule, basically bringing the exponent down and subtract 1 from the power. So it becomes f prime x is equal to 1 over 2 x the power of 1 over 2 minus x the power of negative 3 over 2. So simplify again the equation. I make it 1 over 2 square root minus 1 over square root x the power of 3. For the step 3 is we need to find the x note. Our x is 160.01. We have the 0.01, which is quite annoying to work with since it has decimal. So we are going to find the nearby number. That's easy. So me, I choose my x note is 160. So for our delta x formula is delta x is equal to x minus x note. Our x is 160.01 minus with our x note, which is 160. It becomes 0.01. So after that, we take the x note into the fx and f prime x. So after that, we plug into the function back 160, which is f160 equal to square root 160 minus 2 over square root 160 is equal to 12.4910. And then for f prime, we plug back into the function. So the answer is 0.0390. And the last is we use linear approximation formula, which is, as you can see here. So the last answer we get is 12.491. We need to add both of the function that we got before this, and we times with the delta x that we got earlier. So it becomes 12.491, and that is the answer. So the conclusion for our discussion is differentiation is an important part of the calculus that helps us understand how things change, like speed of growth. To make solving problem easier, we use different rules such as power rules, product rules, quotient rules, and chain rules. So by learning and practicing this technique, we can solve many real life and math problems more easily and accurately. I think that's all.
Thanks, guys.
Yeah, bye.